This week, we talk with Derek Weeks from Sonatype. In the news segment, we go light on bugs to talk about browsers. Android Q gives codecs a quarantine. Verizon releases its 2019 DBIR, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW.
Welcome to Application Security Weekly. This is episode 61, recorded May 13th, 2019. I'm your host, Mike Shima. I'm here with Matt Alderman. Hey, Matt.
Morning. How are you? It is afternoon in the studio, so I do have a cigar, by the way. I don't do this at home. I can only do it when I'm in the studio. The wife will kill me.
John will be jealous. He won't be able to join us today, either in studio or remote. That's too bad. Register for our upcoming webcasts with Kaseya and SaltStack by going to securityweekly.com/webcasts. If you have missed any of our previously recorded webcasts, you can find our on-demand library at securityweekly.com/on-demand. Security Weekly is returning to Vegas this August for Black Hat and DEF CON. If you would like to request a briefing or sponsor an interview on site at Black Hat, please go to securityweekly.com/booking and submit your request. Today we have Derek Weeks from Sonatype. Derek is the world's foremost researcher on the topic of DevSecOps and securing software supply chains. For the past 5 years, he has championed the research of the annual State of the Software Supply Chain report and the DevSecOps Community Survey. Derek is a huge advocate of applying proven supply chain management principles into DevOps practices to improve efficiencies and sustain long-lasting competitive advantages. He is a frequent keynote speaker and industry panelist at conferences like the RSA Conference, Bosch IoT Summit, Red Hat Government Summit, Carnegie Mellon's SEI Software Supply Chain Summit, and numerous DevOps Days events. He currently serves as Vice President and DevOps Advocate at Sonatype, creators of the Nexus Repository Manager, and the global leader in solutions for software supply chain automation. Derek is also the co-founder of All Day DevOps, an online community of 65,000 IT professionals. In 2018, Derek was recognized by DevOps.com as the best DevOps evangelist for his work in the community. Derek, welcome.
Hey, thank you very much. Excited to be here.
And we're happy to have you here too, because for one thing, software supply chain is pretty topical and has been on people's minds for at least something we've been talking about the last couple of weeks, and I think what the industry has been talking about for at least last couple months. And if I'm right, the software supply chain report has been going for at least 4 years now. So, what? Let's start with that. And what's our state of software supply chain?
Yeah, so it's pretty interesting. As you mentioned, the State of the Software Supply Chain report. We're actually actively now writing the 5th version of the State of the Software Supply Chain report that we publish each year. And what that report really talks about is a couple of things. One is the vast consumption of open source components across different enterprises, software development organizations, how much they're consuming of these open source software components into their development practices, and then also discussing the quality of the components that are being consumed across those organizations. So, one of the things that we often like to say is not all these components are created equal. Some have different licenses, some certainly different versions, different performance capabilities, and sometimes security vulnerabilities. And so what we're really doing is making people aware of the consumption of those components, that not all those components are created equal, and that there are things that organizations can do to better manage their software supply chains. And also we touch upon how government is getting involved in software supply chains in terms of putting in laws, putting in policies and regulations cross industry, understanding how software supply chains work, and putting in those kind of policies to make sure that consumers and government constituents out there are safer as a result of it.
Yeah, I was at Global Cyber Innovation Summit a couple weeks ago, and your CEO was on one of the panels, and the statement that was made is, we don't build software anymore, we borrow it. We're borrowing a lot of these subcomponents and then building our capabilities on top of that, but we're borrowing a lot of the core components. And I'm curious, what kind of trends have you seen now that you're in the 5th iteration of this report? What are some of those interesting trends that we're seeing? I would imagine we're seeing more adoption of open source is being used and consumed by organizations. But what are some of those other trends that we're seeing? Are there, indicators on the types and which ones are safe and not safe? I mean, I bet you've got lots of good evidence of what's going on there.
Yeah, so I'll hit on a few things just to start us off, to give us a sense of the scale of what's happening out there. So, if you go to any software development organization, or any organization that is doing software development, and you ask them, are you using open source components? They would say, sure, yeah, I'm sure we're using them somewhere. What you don't necessarily recognize is the volume at which you're consuming these things. So when we've been tracking the consumption of open source components across the industry, we do so by looking at the different development ecosystems that have open source components: Java, JavaScript, Ruby, Python, etc. And we report on some of the volumes of consumption of those components. So last year in the Java realm, for Java open source components, there were 146 billion download requests by about 9 million Java developers around the world. In the JavaScript realm, there are about 6.5 million JavaScript developers around the world. Those JavaScript developers are consuming or downloading 9 billion JavaScript open source packages every week. The consumption volumes are gigantic out there, and they're getting bigger each year. So they're up, anywhere of 60 to 70% year over year for the past several years. Now, what this means to any organization out there developing software is that, somewhere between 80 and 95% of your code in your applications is actually composed of these open source components. That your developers are not writing every single line of their application from scratch, but they're borrowing these open source components from open source projects that are making them available on the internet. And this is the great thing about this is it's accelerating our software development capabilities. I mean, why should I spend an hour or a week or a month developing something that I could download from the internet in a second? And now that we have all these components within an application, we, as I mentioned before, not all these components are created equal. So in the case of, the Java development environments, 1 in 10 of those billions of downloads that I mentioned had a known security vulnerability last year. In the case of JavaScript development, the guys that run the JavaScript repository reported back in October, 51% of their components that were downloaded that had been analyzed in their study had a known security vulnerability. So certainly not all components are created equal, and we're seeing a very high number of vulnerabilities associated with these components being fed into development enterprises.
Yeah, which creates this really interesting challenge is, how do I identify the libraries that I'm using first?
Yeah.
But then more importantly, am I using the good 90% in Java or the good 49% in JavaScript, or aren't I? Because that's creating vulnerabilities. I mean, obviously Struts was a big vulnerability in an open source library that created obviously one of the breaches we've talked about for years. How do organizations now, knowing these numbers, how do they get their heads wrapped around, okay, how do I evaluate this stuff as part of my DevOps process, right? The promise of DevSecOps in a way that doesn't slow down also this development speed that we're gaining, right? Because that's the whole DevOps movement. I mean, this is a challenge that I think organizations would struggle with.
Yeah, there are a number of different ways to unpack the things that you just asked. But often people ask me like, okay, so oh my gosh, Derek, I just heard you say there were billions of downloads, and 1 in 10 or 1 in 2, depending on your development languages, have security vulnerabilities. What do I do? Where do I start? And I think that there's a really basic place to start, and that is, you have to not only understand that open source is being used, you have to understand what you're using. And there's something called a software bill of materials that organizations that are developing applications can utilize, that basically just creates a report of, let's look at an application that we're developing, let's scan it, and that software bill of materials analyzer will tell you what open source components exist within your application. I think that the important thing about this is, if you can't create a list of the open source components that you have within your applications and keep a record of that, then any kind of vulnerabilities that come out that are announced against those components cannot be easily found within your organization. So you refer to the Struts vulnerability that was tied to Equifax and a number of other organizations, Canada Revenue, Canada Statistics, Okinawa Power, Japanese Post, India's Aadhaar Social Security system, all were Struts-related breaches. Well, if you have Struts in your organization or any other open source components, and there's a vulnerability that gets announced against those, you have to ask yourself 2 questions immediately. One, did we ever use that vulnerable component? And if yes, where did we use it? And if you don't have a software bill of materials, you can't begin to answer that question in a rapid way that you can begin to respond and remediate any vulnerabilities that you might have in those components. And if you don't have that software bill of materials, what you basically end up doing is running a scavenger hunt across your application portfolio. So if you remember, 5 years ago now, when Heartbleed was a big vulnerability that was announced, people were like, oh my gosh, am I using OpenSSL anywhere? And they were asking these same 2 questions. Did we ever use that? And if yes, where? And some organizations took 3 or 4 months to figure out across their portfolios, where did we have this component? Where do we have it? And what equipment does it exist? And what applications does it exist that we developed or that we bought from someone, or equipment that we bought from someone? And that was a scavenger hunt within those organizations. If you had a software bill of materials that identified what components were in all of your applications, and for that matter, software within your equipment, then you would know the answer to that quickly, and then you could begin your remediation based upon that.
Yeah, and I'm glad you brought up the software bill of materials. I'm actually working on trying to get someone to come on and talk a little more about software bill of materials in the federal government space, because they're starting to try to push aspects of, look, I need a software bill of materials before I'm going to use this stuff in the federal space. And so I'm trying to get somebody on later this quarter or next to talk about this problem. But this goes back to the age-old problem that I think we've had in information in security space for a long time, is it boils down to inventory. What do I have? What components am I using? What components aren't I using? What's authorized? What's unauthorized? I mean, asset inventory, and it was hard enough in the hardware space. Now we're talking about this in the software space with all these open source components. I think this is a real big challenge for organizations that we have not really been able to get our arms around. And I see that's one of these early challenges.
Here's the thing, you know, if we were talking a decade ago or even more in terms of software development, when much of the code that was being developed was custom written code, trying to identify where certain lines of code are within an application base or application portfolio that might have hundreds or thousands of applications would be extremely daunting as a task. With open source components, the big advantage that we have here, if you think about OpenSSL, was, you know, OpenSSL version 2.1.3 or whatever, you know, versions it was, were known vulnerable. Well, that OpenSSL open source package was the same exact package being used across 3 million different locations, you know, across the internet. It's the same package. It's identifiable. You can almost think of these open source packages as having a barcode, unique identifiers that are the same in every single use case where these things are located. So the idea of being able to identify things that have, you know, a kind of barcode identifier, if you will, to kind of use an analogy people can understand. If you have a barcode on these things that can be identified, you can identify your inventory, and then you can track and trace those components that are used anywhere. On custom code, that's very difficult. But on code that's basically assembled from all of these uniquely identifiable parts, it's actually pretty easy, where you can take supply chain management principles from any other manufacturing industry and apply them in. Let's keep an inventory. Let's track and trace. When there's a problem, we have a recall process that we can go about to identify and remediate these issues within our base. So it sounds daunting when you talk about the billions of components consumed and the different places that these can go. But the solution is actually fairly basic in terms of how you approach it.
And could simplify the problem if we had the right inventory. And I will want to touch on the supply chain validation cycle later, but to your point, if I had the inventory and I knew that this one component was vulnerable and I knew every place it ran, it could actually simplify aspects of the problem. I think the challenge is we don't have that base inventory still yet, so we're not quite there yet.
Yeah, like I said, if you're going to start anywhere, the first thing that you need to know is, what is your inventory? Because if you can't answer that, you can't begin to remediate anything. If you hear a new Cowboy open source component tomorrow has a vulnerability in it, you have to answer, did we ever use that? If you don't have the inventory, you can't begin to answer.
Yeah, I don't want to take over the whole interview, Mike. So but I can keep going for a while on this topic.
No, I think that's great. There's a lot of passion there. And I think that's also a great thing to pick up on because, we have, with NPM, with Ruby, Gem, you can get some package manifests. And so that's really good to at least say, here are the versions that exist in it. What I'm curious about too is once we start to build that inventory, that's at least we can react to know this version of a piece of software, it has a known vulnerability. But there's still a bit of a problem, a challenge with the provenance of these apps, right? And how much trust can we put in them, from everything to typo squatting, so that someone, you thought you were pulling in one particular app, but there was a typo that pulled in a slightly misspelled version, to as well as who's committing. And are these actually getting some back doors in them? Because we've even seen that this year of a Ruby gem having a backdoor inserted into it.
Yeah, so here's an interesting thing that we've been reporting on within the State of the Software Supply Chain report for a couple of years now, and we're again going to update the kind of evolution this year is you have to really look at this issue from the standpoint of adversaries. If you're an adversary, it used to be that you're in a wait and pray kind of mode of operation. And that is, if there is a known vulnerability, then I can go and either develop an exploit or find an exploit and begin to try and find locations where that vulnerability exists. So in the case of the struts vulnerability, Apache announces there's a vulnerability within the struts web application framework. They announce that there's a safe version made available that same day. But the adversaries are rushing toward, okay, how do I exploit this vulnerability, and how quickly can I find instances of vulnerable struts out there? But they have to wait for a vulnerability to be discovered and then act upon it. So it's a very inefficient kind of approach for adversaries to take in this wait and pray kind of situation. Now, take the minds of an adversary and say, how do I make this more efficient of an attack process? Well, if I know that a certain open source component is downloaded 500,000 times a week, that it's very popular, maybe I will socially engineer my way into that open source project to begin committing new capabilities, new features to that particular component. And over time, I gain the trust of that open source project. And I happen to, a couple of months later, slip in an extra space, within a line of code that I commit that creates a backdoor. And all of a sudden, that component being downloaded 500,000 times a week is now everywhere. So I effectively inject the malicious code into that open source project that's extremely popular, gets downloaded everywhere. And now I don't have, and now I'm not in a wait and pray situation. I'm basically injecting my 0 days into that code that's being widely distributed and widely consumed. And from an attacker standpoint or adversary standpoint, you're now a very efficient operation. If you can construct where vulnerabilities are showing up, then you can begin to exploit those immediately, because assuming you put the malicious code in, you also know the exploit path to get at that. That's a really scary situation out there. And we've seen, I think now we're counting almost 14 instances of that kind of attack that we've seen.
Yeah, and one of the other topics we talked about at Global Cyber Innovation Summit a couple weeks back was the rise of espionage and people inserting themselves not only into the business, but to your point, into these open source projects where I can now commit code potentially into these open source libraries that creates my backdoor. And now you're hoping that somebody else finds the backdoor to shut it down, which gives you this expanded window to potentially prey on those environments to try to exfiltrate data out of it. And that's a really scary proposition, because how do you find it in these environments and protect against it?
Yeah, and I think, in the couple that we know of, we were lucky enough that someone had the curiosity to say, well, why was this thing was released on the NPM repository, but not in GitHub, and I didn't see the same version numbers, and I'm kind of curious as to why this showed up, or there was a change in commits that looked abnormal, so I decided to explore it. And found this thing that looked abnormal in that release, and now I'm drawing attention to it. It was only in these few cases that we're actually aware of that those were caught. But the idea of, if Mike decides he's going to make a commit to an open source project and I make a commit to an open source project, and we're both being helpful toward that project, what's the difference between Mike's commit and my commit? And especially if you don't have people on the open source project that are security experts looking at the code and looking at every release and every commit that's happening there, the idea that these things can get out there pretty easily without too much scrutiny is certainly a concern that we have to worry about. What's getting into our code, what is the provenance of that code, and when vulnerabilities do happen to be discovered, can we identify if we've ever used those components, and if so, where?
Yeah, so I want to go down supply chain a little bit, because I think this is a really interesting discussion. Back in the financials, back in the early days of my compliance background, I started in third-party vendor management. And the challenge there was you can outsource the function, but you can't outsource the risk. And we're heading down the same path with software, where we've kind of outsourced aspects of our software development life cycle to the open source community. But we still own the risk as a development shop, I think, right? Because we have to make sure that the code we're using is secure. So we have to do some sort of risk assessment. Do you see a day where we really start thinking about third-party validation of open source as part of the process into our DevOps pipelines to really look at the potential risk of the open source that we're using? How do we do some level of validation, say, look, this is a valid version, we trust this version, because we don't see risk in it? Are we going down this kind of third-party vendor management process with software as well?
Yeah, I think, so certainly no single organization, no single development organization out there can know everything about every open source component that may exist out there at any kind of scale. In software supply chains, if you look across all development languages, we've reported there are something like 15,000 new versions of open source components released to the market every day within the supply. There are 1,000 new open source projects that come online every single day. You can't keep up with the knowledge of what's happening within that community as an individual development organization. So I think this is where you have to rely on intelligence from third parties that tell you about the attributes of those components and what components are safe and what components might have vulnerabilities or might have risky licenses, what the most popular versions of these components are, so that your developers can actually make decisions on, if I'm going to pick any particular open source component, am I picking the best one and the best version of that from the best supplier with the best track record of performance and remediation when vulnerabilities occur, et cetera. So I think there is a reliance on third parties for that kind of metadata about components that can help you make better decisions. But I think there's also a responsibility of the organizations that are developing software to understand what they're putting into the software and to hold themselves accountable for, we're building the best products with the best parts and the best ingredients, if you will, and providing those to our customers. You mentioned some of the work being done in the government around software bill of materials. A good friend of mine, Alan Friedman at the Department of Commerce and their NTIA group, is leading the cross-agency initiative for the software bill of materials. He's working with Dr. Suzanne Schwartz at the FDA that are applying some of this thinking around software bill of materials into the medical device manufacturer's realm. And in that case, to kind of bring it to where can these kind of policies or rules be applied to govern software supply chains? That the FDA is telling medical device manufacturers, if you're going to produce medical devices that have software in them, we want you to do a couple of things. One is we want you to produce an inventory of the open source components in these devices. We want you to say if there are any known vulnerable components in this bill of materials. And if there are, before you can ship that medical device, you need to repair those vulnerable components to make sure that this thing doesn't have vulnerable code when it goes to market. And then they say, if a component becomes vulnerable over time, once it's in market, then you have to repair that vulnerability within that device in a timely fashion. And if you don't repair that in a timely manner, you may be held liable for not updating that software in that medical device in time. So it's not only relying on these third parties that have information about the quality attributes and security aspects of components, but looking at policies and practices that can be adopted by organizations, by enterprises to make their software better. Know what's in it, know if it's vulnerable. If it's vulnerable, fix it. And if it becomes vulnerable over time, be able to repair it in a timely manner.
Now you know who I'm actually trying to get on the show, by the way, because Alan and I have had these conversations.
I can help with that. Alan's a really good guy.
No, he's clearing it. He's clearing it with the PR folks before he comes on. But that's the exact same conversation he and I had at InfoSec World, and I'm like, dude, I got to get you on, because what I think that starts to build, which I think is where part of this goes, is some sort of trusted repository of components at some point. I think the ability to say, look, these components we've tested, we've verified, we've validated, these are trusted sources of certain components, that will drive maybe more organizations to look at that repository as a starting point to bring in open source components into their code. I think that would be a really, really good thing for the industry.
I think so. It can provide good value, but maybe I should point that out as an anti-pattern. There is this thought that if you have a golden repository of these are the safe components that you can use within any development practices, if I go to that repository and use those safe ones, I'm good. The reality, and we like to say software components age more like milk than they do wine, is that a component, the Struts web application framework was safe. In the case of the Equifax breach, it was safe up until March 7th, 2017. But on March 7th, it was named, hey, this thing is bad. So if the good version on March 1st, 2017 was in that repository and you downloaded it, it was safe at that point, but it becomes unsafe or vulnerable over time as vulnerabilities are discovered. So not only would you want to pull from a safe source, but you have to track that component over its lifetime, because vulnerabilities do get discovered over time. And if it does, then you need to know where that is. So yes, you should use the safe version from the start. You shouldn't use a known vulnerable version, but you need to keep track of what you've used over time, because vulnerabilities get discovered, years, months later after these things are released. And you have to know, where those exist or if you ever use them.
Yeah, which means there's an ongoing monitoring component that flags these things and creates, these are the new versions now to implement into your code. Yeah. I think it would help still, even though there is the likelihood that it's going to become vulnerable or could become vulnerable. Yeah. By knowing that it came from the source, you flag it that it's now vulnerable, and you give it the replacements for it. Now you can probably consume that a lot faster, minimize that dwell window of the vulnerable code. I think it would help the industry. But you're right, it's not. I can't just pull that component and that's it. I still have to monitor against that repository to know when things go bad and know what the potential replacements are.
Yeah, I think that also speaks to the responsibility.
Do something versus do nothing, right? So if the only thing that you do is try and have a golden repo, you've done something, versus those that have done absolutely nothing about this. If you don't take any action, then you should be liable for not taking any action.
Yeah, that makes sense. What I was going to add there too, it also shifts that responsibility of who's, within the DevOps, or call it DevSecOps, who's supposed to be keeping track of, that May 7th date or that March 7th date, or, whenever this becomes vulnerable. Because if you do have some type of golden repository, you can at least constrain where packages are being pulled in from. And at the worst case, you can also start to do things like breaking builds. Here is, swap out a known vulnerable package for a README that says, please update your software. That's a little bit of perhaps an extreme case, but at least gives you that ability to be able to start to blacklist and make those types of situations more visible, so the DevOps team doesn't have to sit down and scroll through mailing list updates or other types of announcements for latest security chats or security updates, and actually focus on development.
Yeah, it's on that point, I think that there's a lot of there's information that can be made available to people out there on security teams and in development teams. In this case, we're talking about how applications get developed and whether they're developed with good parts or bad parts. And part of the change that we're seeing taking place. So I run an annual survey called the DevSecOps Community Survey with a number of other vendors in the marketplace. Even Signal Sciences, one of the sponsors of this conversation, participates in this annually with us. And one of the things that we found in there, we asked organizations, this was mainly, we asked 5,500 developers or DevOps professionals, how are you informed of application security issues? And in the mature DevOps organizations, we saw 63% of developers saying, I'm informed of AppSec and InfoSec issues from my development tools. So for instance, GitHub or my Eclipse IDE or my Jenkins build continuous integration platform is informing me of vulnerabilities. So I am getting that security information delivered to me by the tools that I am using. I don't have to go to third-party security tools built for security professionals. I'm actually in the development tools that I use every day. So we're seeing 63% of mature DevOps organizations or the people in those organizations being informed by their tools. Compare that to organizations that don't have a DevOps practice, and only 39% of developers there are being informed of issues through their tools. So I think that the more we can utilize tools and automation to surface this information to developers as they're building their applications, as they're assembling them from these components, the better off we are. I mean, I was giving a presentation in Washington, D.C. a couple of months ago. During my presentation, a developer in the audience says, hey, GitHub just informed me that the code that I have there has a vulnerability in it. Now I have to go and remediate that. It's like, GitHub's not a security tool. Like, what's it doing informing you of security issues? Like, no, this is actually how the development practices are changing, that tools like GitHub have security information that's being fed into them from different third parties. And that's helping developers develop higher quality code at the end of the day.
Yeah, and this is where DevSecOps comes together. It's the integration of the tools into the process and into the pipeline. And this is what I always tell my security friends. If you think a developer is going to log into a separate security tool to go see if it's vulnerable, they're not going to. This data has to be surfaced in the tools that the developers are using, so that they get notified either from a failed build or from their repositories that says, wait a minute, there's something wrong here. And that's the real value of what I think DevSecOps ultimately needs to do. But as security professionals, we have to realize that that data has to get integrated back into the developer tools. It's not a separate standalone component sitting over here on the side, because it'll never get used.
Yeah, and in fact, not only does the data have to play in there, but it's got to be, the information has to be delivered in a way that a developer understands it, because what you would tell a security pro is a lot different than the language you would use to tell a developer. And you have to give them meaningful information about that, information delivered to developers, written for developers that helps them make, better decisions.
Yeah, that's why we like the Signal Sciences guys too, because they get that part.
Yeah, I've worked with those guys for years.
And that's what's cool to see GitHub talking about, for free, they'll give you that dependency. They'll talk about your library dependencies. And even they just recently announced their own approach to package management as well. So it's great to see, these are the tools, move security to where the developers are, seems to be that underlying theme.
Yeah, and we're seeing more and more of that taking place, and it's happening in high volumes. It's not something that's so conceptual and esoteric that like, oh yeah, only 2% of organizations are doing this. No, we see good 25% of organizations are building security integrating security across the development lifecycle, and developers that are doing this, not security teams per se having tools available. And I think that's part of what we see in the DevSecOps community survey is the developers are saying, I'm aware of the tools. The tools are informing me of security issues. I'm more on top of things. I'm more aware of breaches and incidents that happen. And we're evaluating our code in an automated way across the development lifecycle. And we're seeing more and more of that every year.
Great. That's a good trend for DevSecOps if we really want it to get adopted.
Yeah.
And it's like the DevOps, they're doing security in practice, even if they're not doing it in name, just by following those basic steps. I want to say we are also at the basic steps of our end of our time here. But this was obviously a fantastic conversation. And Derek, when can we look forward to the next State of the Software Supply Chain report?
You can look for it to be out this summer. So we are. I am actively writing it. I've been actively writing it for the past couple of months now, and we're also super excited this year. Gene Kim and Dr. Stephen McGill. Gene Kim, who wrote the Phoenix Project and DevOps Handbook, among other things, and Dr. Stephen McGill have been working with us on some of the data research and data science behind this year's report. So we have some, I'm not going to share it at the moment, but we have some really fascinating information coming out on how different software development practices are working across different enterprises. We evaluated 86,000 different development organizations and teams to get patterns in how they work and understanding which ones are more secure and less secure because of those practices. So really exciting stuff. And maybe I can come back in the summer and chat about what we found there.
Yeah, that sounds very exciting, especially dive into that data to understand what trends you've got. Well, we'll absolutely have to get you back on here because I think Matt showed a little bit of interest on the topic as well. So I think we have a good chat. Just a bit.
Cool.
Well, I'm sorry to say, but we're going to have to wrap up here. But thank you so much, Derek. This was a great conversation, and we're looking forward to that report this summer. We'll have you back.
Yeah, super. Thank you.
Thank you. Thanks, everyone. We're going to take a quick break, and we'll return with news of the week.